looking at the probability and genetics data collection part, you might want to set up a sheet of paper similar to mine. I maybe went a little bit further than you would be needing to go, but we do need 2 coins for this exercise. I happen to be using a quarter and a battery that has 2 different sides, so not quite a coin, but it will work. We know that both of our parents are heterozygous, so both parents are big D, little d, which means that they would have a dominant characteristic, a dominant trait, and also recessive. So I think I'll use the side with the writing on the battery for, we'll say that's dominant, and then the other side is recessive. So we need to flip each of these 100 times to kind of come up with a relatively large data collection to kind of see how close we can actually get this to be to the expected 1 to 2 to 1 ratio as depicted by the Punnett square. So we should, based on that, expect 25% of the offspring to be homozygous dominant, and 25% of 100 is 25. So we're going to see how close we actually get to that based on nothing more than probability. Same thing, we'd expect 50% to be heterozygous, so 50% of 100 is 50, and 25% to be homozygous recessive, so 25 out of the 100 we're expecting to be 25. Now, will it exactly be these numbers? Maybe, maybe not. That's kind of what we're seeing is do we not necessarily land on exactly these numbers, but do we get close to those numbers? So in order to collect your data, I would probably recommend using the tally system. So maybe something like this. You'll flip your coins. I got tails and heads, so that would be a heterozygous. Tally, flip, flip. I got heads and heads, tails and heads, tails and heads. And you would simply kind of continue this until you got 100 total tallies. So using the tally system, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If you use the tally system, it does make it a little easier to add up because it's easy to count in fives to see when you get to the 100 cutoff point. You can then add up once you've had 100 total flips. It's not 100 per, it's 100 total, so this column plus this one should equal 100. You can figure out of those 100 how many actually were homozygous dominant, and then you can compare that to what we expected. Same for the heterozygous and for the homozygous recessive. And then you'll be using this information down here to answer the questions that follow within the Nearpod presentation.